right, so we're going to just quick review what we talked about yesterday, which was end behavior. Remember that you're looking to see the highest exponent, okay? If it's odd or if it's even. If it's odd, then the arrows point in different directions. One goes up, one goes down. If it's odd, then you look at the number on the front of that odd exponent. If that is positive, then it rises right, falls left. And if it's negative, then it rises left, falls right. If the highest exponent is even, then both the arrows have the same direction. If it's even and positive, both up. If it's even and negative, both down. Then we talked about zeros and multiplicity. So to find the zeros, we set our function equal to 0. We solve it. Sometimes we can factor it. Sometimes we use the quadratic. Sometimes we have to do our possible roots, find which one works, and then break it down from there. Each of those roots, as long as they are a real root, meaning I is not part of it, they will be x-intercepts. And then we count how many times the root occurs, and that's the multiplicity. If it's an even amount of times, then that point is where the graph bounces. If it's an odd amount of times, then it crosses through. And then we graphed example 1, 2. Well, we did 1 was the end behavior. We graphed example 2 and 3, and this is where we left off. So graph negative x to the third minus 8x squared minus 11x plus 20. First thing I'm going to look for is, can this be, well, let's look at the end behavior, right? So what's the highest exponent? Which is even or odd? Odd, which means I'm going to figure out one of these is going up and one of them is going down. So then I look at the number on the front of that exponent that's odd, and it's a negative this time. So this means this rises right and falls left. Other way around. Yes, I said it and then switched it. This rises left and falls right. Then you want to find your zeros. So I'm going to set negative x to the third minus 8x squared minus 11x plus 20 equal to 0. See if I can factor it. This is 4 terms, but I cannot factor by grouping, which means my next option is to find the possibles. So the possibles here, factors of negative 1, or we ignore the sign, we just do 1. 20 would be 1 and 20, 2 and 10, 4 and 5. So plus and minus 1, 2, 4, 5, 10, and 20. I'm going to try the 1, negative 1, negative 8, negative 11, 20. Bring down the negative 1. And that's the first one that works. So I have negative x squared minus 9x minus 20 left. This time there's a negative on the front, right? So I can actually, because I'm setting this equal to 0, divide everything by negative 1. Change all the signs. And then see if there's factors of 20 that sum to positive 9. And there are. We're just going to keep going. So give me end behavior here. Odd and positive, which means falls left, rises right. Good. Still can't factor by grouping. Dang, Miss Ferrier, she comes up with some good examples. Okay, good news is my possibles are only 1 and 5. Yeah, so plus and minus 1 and 5. Then I get 1, negative 4, negative 2, 5. Start with 1. And that works. So 1 is one of my zeros. X squared minus 3x minus 5. Not factorable. So yay, quadratic formula. So negative b.
Wait, sorry, if it's not factorable, then don't we do the thing where we plug it into another?
That's only if it's not x squared. If it's x squared and not factorable, you'll never find it from your possibles. You have to use quadratic. They were higher. You mean the ones from like from the notes from the day before yesterday? It was factorable. What was left? So the opposite of negative 3 would be positive 3 plus and minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. 3 plus and minus the square root of 9 minus a negative, well, minus 4 times 1 times negative 5 is plus 20 over 2, 3 plus and minus square root 29 over 2. So those are our exact roots. When I list out the roots, there's the one that we found, 3 minus square root 29 over 2, and 3 plus square root 29 over 2. There's my roots. It is plus or minus, but that's a plus and a minus. That doesn't mean something's a duplicate root. That means each of those have a multiplicity of 1. So they're crossing through. And then to graph those, we have to approximate it. So square root 29 is in between square root 25 and square root 36. It's a little bit closer to square root 25, so maybe make it like a 5.4. I always make it even so it's divisible by 2. And then I would do 3 minus 5.4 over 2 and 3 plus 5.4 over 2. Negative 2.4 over 2, negative 1.2, and 8.4 over 2, 4.2. So I'm going to approximate those.
So where'd you get the 5.4 from?
I approximated square root 29. So square root 29 is in between square root 25 and square root 36, right? Which are the perfect squares 5 and 6. And it's a little bit closer to 25 than it is to 36.
So can you just just put that in the calculator? And then
You may not have a calculator. Yeah. So if you had one, yes. If you didn't, no. All right, then positive 1, then 4.2. We said it falls left, it rises right. It's going to cross through that y-axis, so the last thing I want to do is find my y-intercept. Plug 0, 0, 0 in, and I get 0, 5. Remember, it crosses through each of these. So it crosses through, it hits the 5, it comes back, it crosses through. I need to know how low to put that point in between the 1 and the 4.2. So I'm going to plot another point. I would say you want to plot usually halfway between, but since there's not an exact halfway between, you could just pick one. So I'll pick 3. And I'm going to plug it in, and I wrote all over the initial one, so let me erase it. I'm going to plug it into the original. So I'm going to plug in 3. 3 cubed minus 4 times 3 squared minus 2 times 3 plus 5. 3 cubed is 27 minus 4 times 9 minus 6 plus 5. 27 minus 36 minus 6 plus 5. This is negative 9 minus 6 is negative 15 plus 5 is negative 10. So I go all the way down to negative 10. And then I continue my graph. Down and back up again.
wait, so what's the instance where you have to then plug in that bottom?
I would say always you have to have a point in between every pair of points. So like in between this point and this point, we had the y-intercept. So we didn't need to plug in a point. But in between this point and this point, we didn't. The only time I would say there's an exception is if it was literally like 1 and 2. If it's 1 and 2, it can't go that far down. It will be a short dip. And I won't make you plug in a half, like a 1.5, especially not without a calculator. So you can just eyeball that. The good news is with these, you already have like the roots. They're pretty much there. You just don't, you have to do one step to get them. But this is already, these kind of examples are already factored for you. The hard part is the end behavior here, because it's not as obvious, right? So if you think about what happens, and here's the good thing, is that if I were to actually expand this out, x minus 3 squared, what's the highest exponent I get from that? X squared. So don't think about the whole polynomial, just think about the highest one. Then this would be an x, then this would also be an x squared, right? So if I was to multiply those out, remember when we multiply multiply exponents, we add them, I would get x to the 5th, because it'd be x squared times x, which is x to the 3rd, times x to the 2nd, which is x to the 5th. That's really all I need out of it. I don't need the rest of the stuff yet, because I already have the roots. They're there, okay? But the negative is still on the front, which means that the leading coefficient here would be negative x to the 5th. That tells me the exponent is odd, so this falls, it's odd and it's negative. So this rises right, rises left, falls right. So you, like I said, could go through the process of multiplying all of those out. I'd have to square the x minus 3. I'd have to square the x plus 1. Or just do the highest exponents in each one. So the x would get squared, then it'd be multiplied. So this x would get squared, then it'd be multiplied by this x, then this x would get squared. So it'd be x squared times x squared, which is x to the 5th. Yep.
How did you find the 1 yourself? Did you just multiply the negative 3 times the 1?
Not yet. Wait, sort of. But you have to square it first. Okay. Yeah. So then that's the trickier part. But then the easy part's the roots, right? Because I would just break each of these apart. So if it's x minus 3 squared equals 0, and then x plus 1 equals 0, and then x plus 1 squared equals 0. So how many roots come from x minus 3 squared? There's 2, right? This is x minus 3 times x minus 3, right? There are 2 3's coming out of that parentheses. So this is 3 with a multiplicity of 2.
What about the negative in front of the x minus 3 squared?
That negative would go away if I multiplied by negative 1. So I don't have to worry about that in part of my zeros. It affects my end behavior, but not my zeros. Then the x plus 1, there'd be 1, negative 1. The x plus 1 squared, there'd be another 2 negative 1s. So how many negative 1s do I have in total? 3. The one from the middle and the other 2. Does that make sense? So it's less work because you don't have to do the possibles and all that stuff as long as you understand these little tricks. So these are my zeros. Now the y-intercept is not as easy because I don't just cancel everything out. So I would say that y, which is same as f of x, equals negative 0 minus 3 squared times 0 plus 1 times 0 plus 1 squared. So everywhere there's an x, I plugged in the 0. I get negative 0 minus 3, negative 3 squared times 1 squared. Negative 3 squared is 9, but the negative's on the front. So negative 9 times 1 squared, which is 1. Negative 9 times 1 is negative 9. And there's my y-intercept. So now I've got negative 1, 0, negative 9, and 3. My rises left means there's an arrow up here, falls right, arrow down there. The negative 1 has a multiplicity of 3. It is going to cross through it, which makes sense. It's coming down to hit my y-intercept. It's going to come back up, but instead of crossing through this, which wouldn't match my end behavior, it's going to bounce off that positive 3 because the positive 3, because the positive 3 has a multiplicity of 2. If it's even, remember, it bounces.
So for the bounce, you don't like go.
You can't go through it. It hits that point and turns around.
But only if it's.
Only if it's an even multiplicity. So because it happened twice. Yep. So this time, I don't have to plug in any extra points because I had the y-intercept that was about midway between those two, and then there's nothing else on the other side. Does that make sense?
Why can't it go through again?
Because it has a multiplicity of 2, a multiplicity of an even number says bounce. It says hit this point and turn around, do not cross through it.
Are there any other circumstances that can happen, or is it just multiplicity of?
Just multiplicity, not 2, an even number. So 2, 4, 6.
Okay. And it's
All right, we're going to do this one a little faster because it's the same kind of thing, okay? So if I took that first parentheses, the x would have to be squared. This would be x squared. This parentheses, the x would have to be squared. That's an x squared. So my highest exponent is going to be what? X to the 4th. X squared times x squared. And then there's a negative on the front again, so it would be a negative x to the 4th. What's my end behavior? What happens when it's even and negative?
it goes both ways, right?
Both down. Even or both up or both down. Think about a parabola, right? Even, just think about a parabola. Even and positive, they both go up. Even and negative, they both point down. So when in doubt, go back to a parabola and a cubic function, because those are the initial ones, right? Okay, so now that both my arrows are pointing down, then I go back, the easy part, right, and look for my zeros. So what are the zeros coming from this set of parentheses? The first one? What's the value if I set that equal to 0? Negative 2. And how many of them are there? 2. So the multiplicity is 2. Go to the next one. What's the answer? What's the root coming out of there? 3. Positive 3, right? It would be the opposite sign. And how many of those are there? 2. So it is bouncing off of both of these points. So I have negative 2 so far, positive 3, both arrows pointing down. The y-intercept would be negative 0 plus 2 squared times 0 minus 3 squared, negative 2 squared times negative 3 squared, negative 4 times 9, negative 36. Way down here. That's not going to be to scale, but I'm going to plot the point and label it because I don't want to go all the way to negative 36.
Not the y-intercept?
That's the y-intercept, yep. So think about why it's happening at that point's below where I am. What did we say happens at those 2 points? Does it cross through it or does it bounce? It bounces, which means this immediately turns around, comes all the way back down here, comes back up, and then bounces again to finish off the graph. Something would have been different. If it would have been odd, your end behavior would have been different. Both arrows are pointing down.
If the multiplicity was odd, how would we have done that?
So if the multiplicity was odd on one of those, then my x would have been raised to an odd power. And if it was raised to an odd power, one of my arrows would go up and one would go down. So it changes the whole shape of it.
Okay, thank you.
You're welcome. I am going to save this one, save number 9, and we'll do that one like as a warm-up tomorrow, okay? And this, I'm going to say I want to skip to the graphing utility one. So use the graphing utility to graph this. This is where you get really good at your graphing utility, okay? Because obviously it is a key component. So if the homework says use the graphing utility, I think yours just says to verify, but let's say the test says use a graphing utility. This would be a separate part of your test is what we're planning. You would have to. There is no way to graph this. Well, there is a way to graph this one without. But there are times in which there's no way to graph it without. So I'm going to type this in. Parentheses, x squared plus 3, close my parentheses, open the parentheses again. X minus 1, close the parentheses, squared, and x plus 4, close the parentheses again, hit enter, hit graph, and there's my graph. So notice I don't even see the top of it. I know it goes up and comes back down, but I don't see how high it is. There's a couple of ways to adjust this. One is to zoom. So if I go to zoom, and I zoom out, which is 3, I hit enter again, and it's going to zoom me out. Now it's really hard to see my x values, and I still don't get the top of my graph. That means this is going way up to the top, coming back down, and then coming back up again, okay? I can zoom out again. Wait for it. And now I barely see the rest of the graph, okay? So what you can do, the easiest way to figure out, like if you want to get that part, if you want to see how high this is, then pay attention to your roots here, right? So this is a 1 with a multiplicity of 2. This is a negative 4 with a multiplicity of 1. This would be plus and minus square root 3. So I'm gonna go back. The way I reformat is you can either go zoom, and you can go zoom back in, or you can adjust your window. So I went all the way out to negative 160 to positive 160. Normal window is negative 10 to 10 on both the y min and the x min and the y max. That's your normal window. So that's like your standard graph. So notice if I look, sorry, say that again.
How did you get to the window?
Go click the button that says window, and then on the x min do negative 10, x max 10, y min negative 10, y max 10.
Okay, thank you.
You're welcome. So then if I know that, and based on what I also know about my graph, I would know I have a coordinate point at negative 4, 1 at positive 1, and then root 3 is like 1.7. So that makes sense with what my graph is doing. It's arrow down on this side, arrow up on this side. It crosses through. Wait, just kidding. This would be negative. This would be an imaginary root. So these don't work. Right? If I had negative 3 and I square rooted it, it would be imaginary. So the roots just come from positive 1 and negative 4. It crosses through negative 4, goes all the way up, comes back down, hits positive 1, and bounces. If it says use the graphing utility, then you just need a screenshot of your calculator. And we're going to go a little further with these when we get into like figuring out zeros and eliminating from there. But that's what you want to get comfortable with, is being able to graph it and kind of match it with what we know about the graphs.
Wait, what were you planning on doing with x squared plus 3?
I tried to solve it like it's a root, right? But if I set it equal to 0, I get a negative. You can't square root a negative. You can, it's an I, but it's not going to be on my graph.
So you just follow what the calculator said.
Yeah, and it should match up with what you would normally get. So look at this one. That would not be fun to graph by hand. So I type it in. This time I'm going to do the graphing utility on the iPad. Come on. There we go. So x to the 5th plus 5, x to the 4th plus 16, x to the 2nd plus 15x minus 45.
You skipped 8x to the 3rd.
Yes, I did. Thank you. Where's my... Well, and I don't even need to put it in that order as long as it's the same sign. But I'll go back and do it there. Oops. 8x to the 3rd.